let's see where you guys got. So if we break the problem step by step, so the first thing we can calculate, we don't know, is how much sediment was exported or crushed during that whole summer melt season. And to do this, we can just use simple calculation of multiplying the concentration of the sediment in the water times the amount of water that was coming out. So suspended sediment concentration times your discharge. And we do this calculation, and if I didn't mess up my units here, though a lot of this exercise is a unit exercise, we see that that the glacier exported on the order of 1.5 teragrams of sediment, so 1.5 times 10 to the 12 grams of sediments over summer. Now that we know how many sediments were potentially being crushed, so here we're assuming that everything that is being exported has been freshly generated. So how many moles of hydrogen does this crushing could potentially produce? So we now know that the sediment, and if we multiply this by the hydrogen production rate, we get a number of mole of hydrogen that could potentially has been produced. Now, if we remember that methanogenesis using this particular produce uses a 4-to-1 ratio between hydrogen and methane. So here we're just dividing the number of hydrogen mole by 4. We get this. And then if we compare this to our overall measurements of 6 to 10 megagrams of carbon, so how many grams of methane this corresponds to, we can see that, in fact, this could only support roughly about 1% of the overall methane that is exported. So again, we're making a lot of different assumptions. We're using experiments from a lab, transposing to the field, but this is just to show that sometimes assumptions can be different from the real world. But in fact, this actually matches what we observe in this particular case. So if you look at the stable isotope signature of the methane that came out, and if you want to know more about this, you can look at the lecture on cold seeps, which go into detail about how we can untangle sources of the methane. But just to say that all of these dots here corresponds to the methane coming out of the river, and most of these have a chemical signature that looks like organic carbon or acetate was probably fueling the methane. And in the white box here, this would be methane that has a signature produced from hydrogen. So in fact, observation kind of matches what we expect. This is not to say that hydrogen production might not be important beneath subglacial environments. This was just one example. And if we look at data, so these vertical bar here of methane coming from deeper beneath Greenland, we see that a lot of methane has been identified coming from hydrogen generation. So potentially this reaction might be important in other sectors beneath the catchment. Thank you.